Assalamualaikum and hello everyone. My name is Rosakina Alia and we are from group I. We present our product of pil LajakKuruih-I. This is our group members. The first one is Nabila, next Zhanghan, Rosakina, Russell and Sharvin. LajakKuruih tablet is a health supplement diet tablet produced by LajakKuruih company. There are 15 different types of tablet produced by this company in January 2020. So for this presentation, our group will present and analyze about pil LajakKuruih-I. There are 200 sample data from different properties in which the weight, relative density and tensile strength given, and the data are randomly picked from 3 production shifts, which is morning, evening, and night. The objective of this presentation is to assure that the production of the tablets are running smoothly and followed the standard by the Food and Administration FDA authority. The first part is to summarize all the data given into 3 observations, which is in numerical, tabular, and graphical form. Firstly, we summarize the data by each shift and calculate the total for each properties. Next, in numerical form, we calculate all the importance parameters, which is the median, mean, mode, standard deviation, and variance for all 3 properties of weight, tensile strength, and relative density.
Hi, Assalamualaikum. I will present part A for the tabular and graphical method. I had summarized the data by the count of each weight, relative density, and their tensile strength. For the first table, we could see that the weight of 340 to 350 mg has the highest count. Next, we will move to the relative density, which shows the count for 85 to 90% is the highest count. The last table is for the tensile strength, which shows the 7 to 7.2 megapascal shows the highest count. Other than graphical method would give us better view as we can see the difference easily. From the column and pie chart, we can easily find the highest count for the weight, for the relative density, and also for the tensile strength. We could also see the consistency of the production as the highest count for each characteristic is not much different from the lower and the upper count. From the summarization of the data, we could see that the production of tablet I is acceptable since every characteristic shows consistency in their production. That's all from me. Thank you.
Hello, my name is Russell Austin Fu, and I will be addressing the second part of our report, which is if LajakKuruih tablets follows the normally distributed weight of 350 milligrams and a standard deviation of 14 milligrams, and whether there is significant evidence that the LajakKuruih tablets do follow this distribution. So for this calculation part, we are breaking it down into 4, which is the hypothesis, the test statistics, the decision rule, and the conclusion. For the first part of this, we need to see our hypothesis, and our hypothesis states that the weight of standard tablets follow the normal distribution of 350 milligrams. And our opposing hypothesis states that the weight of standard tablets does not follow the normal distribution of 350 milligrams. For the test statistics, on the next slide, we have seen that we have broken down the category of our data into 8, following their ranges from 320 to 390, and we have calculated the probabilities of each of these slides. On the next slide, we have determined the x-squared test with the method of chi-squared distribution, to be specific, the goodness of fit test. And we have used the frequency and the n, which is the total frequency or the cumulative frequency of everything. And we have used the formula stated here to calculate the x-squared test. And from the data tabulated and calculated, we can obtain that x-squared test in total is 3.0228. If x-squared test is more than x squared alpha v, we will reject HO. As seen in the right side of the picture, this is a chi-square distribution. If the x squared alpha v is the critical zone, the x squared test must be smaller than the value, as the value smaller than x squared AV will be the acceptance region, whereas anything beyond that will be the rejection region. And from the table of chi-square distribution, we obtain that x squared, 0.05 and 5, which is the alpha, and the v, which is the degree of freedom, makes the values to 11.0705. And the decision rule is, since x squared test is smaller than x squared alpha v, we do not reject HO, since 3.0228 is smaller than 11.070. In conclusion, the weight of standard tablets follows the normal distribution of 350 milligrams, and this is a significant evidence that the LajakKuruih tablets do follow this distribution.
Good day everyone, I would like to continue with my part, which is question C, which states about is there any significant difference between the tablet weights from different shifts. So we proceed with the method which we are going to use one way ANOVA in Microsoft Excel. The purpose of doing this is to decide if there was any difference occurring between the population of the weights which the sample came from. So as you see, the hypothesis test is as it's stated in the slides, and we will go on with the Excel output of the summary. So we will use the Excel and we are going to differentiate the groups into 3 shifts, which is evening, morning and night shift. So from that we can proceed. We click the data, and through Excel we'll get the ANOVA table, we'll get the source of variation between the groups and within the groups and the total. So from this we will obtain the p-value, which is 0.743087. This p-value is greater than the value of alpha, which is 0.05. So if the p-value is greater than the a value, the h would not be rejected. If the p-value is less than the a value, then it suggests the sample data provided sufficient evidence to reject it. So when we compare it with the p-value, the p-value, which is 0.743087, it's greater than the value of 0.05. Thus we do not reject the value of h0. Thank you.
Linear regression model by predicting the tensile strength and reactive density of LajakKuruih-I for PUI. And the study has shown there is a relationship between the tensile strength of a PU and the reactive density regardless of shift. And the tensile strength is a dependent variable and reactive density is an independent variable. And this is the type of relationship. There are two. One is linear relationship and one is non-linear relationship. Then the linearity test is conducted to test if a relationship between the tensile strength and the reactive density is linear or non-linear. And the linearity test result conclude 95% confidence in linear relationship between the tensile strength of the PU and the reactive density is valid. And the equation used is to describe in this relationship is y equal to mx plus c. And the equation represent each of the coefficient, which is y equal to tensile strength of PU and x equal to reactive density of PU, which is independent variable and independent variable. And this is the SL analysis model to estimate the linear equation coefficient as shown below. And linear regression equation is obtained as this equation. And this is a chart comparison. And well, the blue dot represent the tensile strength data provided by the question, and the orange dot is the predicted tensile strength. And the estimation error, the equation obtained is counterintuitive to the fact that the tensile strength should be 0 when reactive density is 0. Means that the value of intercept C should be at 0 when there is no test. And reasoning, reactive density equal to density of PU over by density of reference material times 100. and the density is equal to mass of pill over volume of pill. And the relative density of 0 means there is no pill that is tensile tested, and the tensile strength data should be 0 when no test is carried out. From the Excel estimate, the intercept C is this value, and the standard error of estimate for the intercept C is 31.37%, and the gradient M is this value, and the standard error of estimate for the gradient M is 0.356%. And the hypothesis test results conclude from the hypothesis test on the variety on intercept value of C, and the intercept C is 0 in value with the 95% of confidence. And this is the predicted tensile strength data from linear regression equation. For the relative density 68%, 74.3%, 80.1% is the question given, and this is the predicted tensile strength. And there are method of calculation using relative density of 98% as an example. And here show the lower limits. And this show the range. And the prediction accuracy. For example, we take the tensile of pill at relative density of 86% is 7 megapascal and get the prediction accuracy. And the conclusion, the linear regression model is a valid model to predict the test result from the tensile strength of the pill based on the relative density with up to 95% accuracy.